Hello everyone, my name is Andrew. Today we'll continue learning programming and today we'll talk about protocols. And why are the protocols so important? So let me give you an example. We have two people here, person 1 and person 2. And the only difference between apes and people is that people have protocols. That's actually the only difference. We are basically the same, our biology is the same, but the only difference is that we have protocols. So let me give you an example. You have a transmitter or you have a walkie-talkie. So the thing that you press on and you can speak to it or you can listen to it. I think you know what I mean, a transmitter or a radio. And if two apes, so if two monkeys have two radios, two transmitters on, so monkey number 1 and monkey number 2 have two transmitters, what's going to happen? They're just going to press on the button and shout in that transmitter, even if they can understand each other, even if they can speak English or any other language. They're still going to just scream into the walkie-talkie. And what's the problem with this? Is that if you have two separate systems that are connected to each other, or two separate people, two separate computers, doesn't matter, and the computers do not have a set of rules that they're going to use in order to speak to each other, then the communication is impossible or almost impossible. So once again, as I said, if you have two transmitters and we give them to the monkeys, monkeys are just going to shout in that transmitter. But as people, we can say, I don't know, we can have a word like a banana. I'm going to say, hello, my name is Andrew, banana. And that banana is going to tell my other party, my friend, my colleague, I don't know, the person on the other end of the radio, that my transmission is complete. So I'm going to say, hello, my name is Andrew, banana. Then the second person is going to say, okay, he completed his transmission, his sentence, his thought is complete. Now let me say something. He's going to say, hello, my name is Patrick. And going to say banana again. And with that word banana, that's the simplest protocol, the simplest rule that we follow in order to communicate. We're going to be able to hear each other because nobody is going to talk over another person. And once again, protocol is just a set of rules. In our case, our rule is that once we hear the banana, so once we hear the word banana, we can stop or we can understand that the person stopped their thought. The sentence is complete. And the same goes for internet. So imagine you have two computers instead of two people. How are they going to communicate with each other? Because one computer can send so imagine that we need to send the word text from person 1 to person 2. How are we going to make that happen? Well, what we need to start with is an OSI model. What's an OSI model? Basically, that's a model that will allow you to build a network. If you start with nothing, if you start from the scratch, so you have, you have a pipe, you have two wires, you have 3 computers, nothing is connected, you don't have Wi-Fi, you don't have routers, you don't have any infrastructure, you can use that OSI model in order to build a network. If you want to improve networks, if you want to work on those, you need to know about OSI model. So basically what does it tell you? Is that we have 8 separate layers and each layer represents a different infrastructure of our network. So if you have 2 people and we want to establish communication between them, we need to use an OSI model in order to connect them. So we can go from the physical layer to the application layer. Application layer is the layer that we as programmers are going to use. And I also have an example of a simple server and a simple client. So that's a simple chat in TCP/IP, but I'm going to show it a little bit later. So that's an application layer. Here it is. That's our code. But we also have a physical layer, data link, network, transport, all of those. And if we go from physical layer allows you to transmit real data. Of course, each layer has a protocol because protocol is basically a set of rules. We can use protocols everywhere. So for example, if we have an authentication system, we need a password and a username for our user to log in. We can say that the protocol for that user login is a password or a valid password from the database and a username. That's going to be a protocol because in order for us to access some secret services, so some or protected rather services, not secret, that are only available to the public once they logged in, we need to use some protocols in order to authenticate our user. That's basically the protocol, a set of rules. However, you don't really need to know all about this stuff because if you know, it's going to be better. Well, I know, and I'm the best. Of course, yeah, I don't know everything, but I know some stuff. You don't really use it on a daily. It depends where you work, but as a web programmer or as a typical programmer, you're not going to really use it. But it's better to learn it because that's, first of all, really interesting. And second of all, it's still going to help you sometimes. But OSI model is just how to build networks. However, all the important protocols are in the network layer and application layer. Of course, presentation, session, and so on and so on and so on. Because we need to do two things in order to connect. So once we have a network, we need to do two things. First of all, we need to know where do we send our data. And second of all, we need to know how do we talk to each other. What I mean by that. So let's say that we have three people here. So person 1, person 2, and person 3. And we only want to send our message to, we are person 1, and we only want to send that message to person 2. I need to know where is that person located, or where is that system, computer, or any other thing located. Where is it? And I do not need to show my message to anybody. I don't need to send it to 3, to 2, or somewhere else. I only need to send it to the person number 2, only to him. And that is routing. So you need to route your message to a specific computer, to a specific system. How are you going to do that? Of course, we have IP addresses. IP address, or IP, Internet Protocol, that's the whole word. So IP, Internet Protocol, allows you to route your message from someone to someone. Person 2 knows who sent this message. Person 1 knows where to send this message. And IP is a really, really powerful stuff, because nothing will ever work without IP. Because let me give you an example. I went to that app.diagrams.net website. In order for me to know where that website is located, where the application is running, I need to know the IP address of that server. We're going to know how to transfer this, or how to convert app.diagrams.net to an IP address a little bit later. But basically, I need to know the IP of the application. If I don't know the IP of the application, I can, well, what can I do next? I actually cannot do anything, because I do not know what application am I going to work with. If I want to send a message to my friend, I do not know where to send that message. And that's why IP is the most important protocol out of all of those. Because we can remove any other protocol, but we cannot remove IP. Of course, IP protocol has some other alternatives, and they're widely used. For example, ICMP. It's not really an alternative, but it's a separate protocol. So, yeah, but one protocol that is really, really important in any kind of network is routing. It's IP in internet, and I'm talking about the internet today, but it's really, really important. And then what's happening? Then we have TCP and UDP. What are those protocols? Maybe you've heard TCP and UDP, TCP and UDP. IP shows us where to send the message. So person 1, person 2, or both of them. But TCP or UDP show us how are we going to talk to each other. Let me give you an example. So let's say that person number 2 speaks Chinese. Person number 1 speaks English. Person number 2 does not know Chinese. How are they going to communicate with each other? Because basically, language or different languages are different protocols. As I said, the difference between monkeys and humans are protocols. We have different protocols or languages that we use in order to communicate with each other pretty well if you know the language. But if I do not know the language, if I do not know Chinese, and I don't, then it's going to be really, really hard for us to speak to each other. And the same goes for the systems. So if your system knows about English or about TCP, because TCP is a set of rules, as English is a set of rules, words, and so on. If your system only knows about TCP, then you should talk to the other system in TPC. So basically, once you establish a connection, you need to use the same protocol, the same set of rules in order to talk to each other. That's the basic idea. So if person number 1 uses TCP, person number 2 should use TCP as well. Like this. Tun, 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 tun. If one of them uses a different protocol, they are not going to be able to communicate. What is the difference between TCP and UDP? As a web programmer, what you need to know between TCP and UDP is that TCP is a protocol that ensures your messages. So basically, we need to ensure that our message is fully there. Let's say I want to send, hello, my name is something. So let's say I send this message from person number 1 to person number 2. When we send different messages, we have something called packets. Because basically that message can be really, really long. Imagine that we need to stream a movie. A movie is like 2 hours long. Lots of data, lots of sound, visual data, all that, all of this. And what do? We just basically get our message and we split it into different packets. So let's say that semicolon represents different packets. So the first thing that I'm going to send is just hello. So imagine that it's going to be really hard here, but imagine that we send the whole message. So we send those packets. And how does it work? The first packet is being sent, then we send this next packet, then the next packet, then the next packet. We split our message and send different parts of that message, and then we just merge it together on the client. And let's say that our person number 2 received this. Hello, my what? We know that that message is incomplete. What does it mean? That means that some packets were lost. What does it mean? That means that the whole message was divided into small parts, and some of the parts were lost. However, again, if we use TCP, what does it mean? That means that our message is ensured, our packets are ensured, everything will be on the other end. And that means that we cannot have hello my in TCP. Of course, in theory, we can have that, but not in, well, you're never going to have that in TCP, because I've never seen it personally. I've seen some packets being lost, but what do we do with lost packets in TCP? So if something happened to a packet, let's imagine that we had a blackout, or we had a fire, or our computer just exploded, just randomly exploded, or something happened to the packets. I don't know, something happened to the Wi-Fi, your network broke down, something happened, so on and so on and so on. What's the problem there? The problem is that, well, your packets are lost. You don't have the whole message. What am I even talking about? Yeah, but in TCP, we don't have that, because once we know that the packet is not there, we have seek, so sequence and acknowledge codes for that. So we send different codes for that thing. Once we know that the packet is not there, what we do is we resend the packet from person 1 to person 2. And basically, most of the times, you're going to have, hello, my name is something. So you're going to have the whole message from client number 1 to client number 2 in TCP. That's how it works. But the problem is that TCP is slow. It's kind of slow. It's not really slow, and yeah, I don't know, it's not really slow. But that check, that sequence, acknowledge, so I got this, I got that packet. So all that thing, all that check for the packets to be delivered, for all the packets to be delivered, it takes a lot of time. So what do I mean by that? Every time we need to check that the packet was delivered, we spend some time on ifs, on checks, on some other code, on some other program code that we don't really need to. Of course, you as a programmer are not going to do that. You're not going to write if packet was delivered, do something, if it was not delivered, do something. But still, we can save some time on this. And UDP is a protocol that saves that time. So once again, in TCP, we ensure our packets. The whole message is going to be delivered. In UDP, what do we do? Is we just send the message. Just like this. Just like, whoa, whoa, whoa. Just send it. That's it. That's the only thing that we do in TCP. And why is it so important? Because TCP is much faster. However, if the packets are lost, well, it's your fault. I don't know whose fault it is, but yeah, if the packets are lost, well, they're lost. Nothing can happen with it. Of course, we can make it so the packets are delivered, but nah, don't do that. If you want me to talk about networks even more, I'm gonna show you how TCP and UDP are different. Where are they different and how do they really work? Because all this is just I'm just scratching the surface of TCP and UDP. But basically, UDP just sends the packet, but it's faster. So if you use UDP, your connection is going to be much faster, but it's not really, you're not ensuring your packets. And that's really, really bad in today's world. And that's why we go to HTTP. So TCP and UDP, okay, TCP ensures packets, UDP does not ensure packets, but it's fast. What's after TCP and UDP? We go to HTTP. And if you look here, HTTP is the most popular protocol on the network. HTTP is a protocol. S is just secure. So HTTPS is an encrypted version of HTTP. They're the same, it's just encrypted, secured. HTTP secured. And what we have as HTTP? Hypertext or Hypertext Transfer Protocol. What's that? Well, basically, when you started working with HTML, CSS, so that's HTML, I think you know about it. If you don't, well, you don't really need to watch that video because it's a little bit early for you. We started working with HTML, we started working with other things like JS, CSS, all that thing. We needed a protocol that will allow us to transfer data from our client or from our server to our client, transfer some web data. And we came up with HTTP. Well, me personally, I came up with HTTP. And HTTP is a really, really, really great protocol, not only for the web, but for communication in general. Why is that? Well, of course, it depends, but HTTP is widely used. It's almost the most popular high-level protocol, almost. Of course, we have other protocols like TCP and IP, and they're used well everywhere. If you use internet, you use IP. So IP is the most popular protocol forever. But I think you know what I mean. HTTP is really, really popular because all of those requests, except for the images that go with data. So that's an image or SVG, the data image, all of those requests are HTTP. So if you go here, headers HTTP, 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 all of that is HTTP. And why is it so important? Because why do we need HTTP? Why can't we just use TCP in normal network communications? Let me give you an example. If I go to my code, I wrote that code, that's a TCP/IP server. So let me run it. TCP/IP server, you don't really need to know about that code, although I have some videos on Twisted that allows you to write similar applications. I have some other videos. I have a separate course on Twisted. So what I have here is my server in main.py and my client in service.py. The names for the files are wicked, but who cares? Let's go to main.py and you see new client connected because I opened up a connection here. Let's write hello, and you're gonna see that it says hello here and hello here. So what we can do with that simple server is we can send messages between different hello my message. You can see hello my message here and hello my message on the server. We can send different messages from one client to another. But what is the problem with this? Because that uses TCP and IP. Okay, so can we use that in real life production grade applications? Can we use that in in some web applications in our startups? Actually, we cannot. And why is that? Because TCP is really, really low level. TCP tells you how to send your data. So as you can see here, even here I need to, when I say send messages, I need to split my messages into different chunks. Chunk is kind of like a packet. That's just the name of the variable here. When I go to main, I need to control all the clients by myself. So we have what? 30 here and 27 here. We have 60 lines of code in total. We have our client, we have our server. But we have 10, 12, maybe 15 problems in total. One problem is our client handling, when to open the connection, when to close the connection. The other problem is encryption. We don't have any encryption at all. The other problem is IP addresses. How are we going to connect to our client? The other problem is packets. We have lots of problems, millions of problems here, and that's just 30 lines of code. So people thought, okay, we don't really want to mess up TCP because it works, and we don't want to mess up UDP because both of them work. But we need another protocol that is gonna ease our use. So HTTP is basically an easy version of TCP. Of course not, because HTTP is for hypertext transfer. But what it allows us to do in abstraction, if we think about it, what it allows us to do in abstraction, in abstract world, is get that TCP, get that hard piece of protocol, all of that, and convert it to something simpler. In our case, HTTP. So if we look at HTTP, it has lots of data to help us work with it. The date of our query, caching. So when does the cache expire? The server. What encoding do we accept? What content type do we accept? What encoding do we use? Caching, once again. Then some security things. So lots of things are in HTTP. Aside from that, we have status codes. Well, 200 is everything okay. 404, not found. Nothing was found. Request method. We have different request methods. Get for retrieval of data. Delete for deletion of data. You use create to create some data, or sorry, not create, but post to post some data to create some data. Patch to update some data. Put to update some data, and so on and so on and so on. So basically, HTTP has lots of settings, lots of things that we can add, remove, or change in order to help us work with it. That is really, really, really important, because the only idea of that kind of protocol and the OSI model is that to go from easy to very, very hard. We would not be able to work with TCP and UDP in production grade applications. Imagine you need to write, I don't know, let's say you need to write this app in TCP. The app has different URLs, the app has different requests. The app has lots of buttons, lots of things that you need to handle. It's going to be really hard for you to write all of that in TCP. But with the help of HTTP, it's really not going to be a problem. Of course, it will be, because HTTP still has lots of things that you need to consider, but it's going to be much easier for you to write in HTTP if you want to write a production-grade application. That's kind of it. So that's the whole idea of protocols. If you want to have other videos on protocols, comment down below. Thank you for watching. My name is Andrew, and bye-bye.